right, Unit 2, Day 4, we're going to talk about multiplying with fractions today. All right, so we're going to go through the next couple of problems. Example 1. You work for a candy company and are changing the size of bags of candy. The new bag has 5 out of 4 the number of candies as the original bag. The original bag had 20 candies. How many candies are in the new bag? So we're going to think about this in terms of here's our bag of candy. So if we go to the original one, this bottom number tells us how many parts the original bag was split into. So we're going to split it into 4 pieces. And those 20 candies are split into 4 different parts. So if we take 20 divided by 4, that'll tell us how many are in each part. And in this one, that becomes 5. So there were 5 candies in each part of the bag. And if we think about this first part, that's 1/4, 2/4, 3/4, and 4/4. Now we have to figure out how many candies are in the new bag. And the new bag is 5 out of 4. So we're going to add another part here, making it larger than the whole. And that's still the size of a fourth. So this would become our 5 out of 4. And remember, each part has to have the same number of candies. So because these first 4 parts all had 5, this last part is also going to have 5 candies. Now this would be the size of our new bag. So our new bag, if we count up all of these candies together, is going to have 25 candies. Awesome. Now let's look at our next problem. You work for a candy company and are changing the size of the bag of candy. So the new bag has 8 out of 5, the number of candies as the original bag. The original bag had 15 candies. So remember, our denominator tells us how many parts the original bag was split into. So this one was split into 5. So we have 1, 2, 3, 4, 5. And in our original bag, we had 15 candies. So to figure out how many candies were in each part, we are going to take the original amount, 15, divided by the number of parts, 5. And that will give us 3. So that means there were 3 candies in each part of our original bag. Now we're going to make our new bag. And our new bag was 8 out of 5. So right now we have 1/5, 2/5, 3/5, 4/5, 5/5. Now we need to add on some more. So we would have 6/5, 7/5, and now 8/5. And again, each part has to have the exact same amount of candy. So because the first 5 parts all had 3, the new parts are also going to have 3. And that will give us the size of our new candy bag. And if we count all of those up, we are going to end up with 24 candies. Awesome. Our next problem. You work for a candy company, are changing the size of bags. The new bag has 7 out of 6, the number of candies as the original bag. The original bag had 12 candies. How many candies are in the new bag? So I want you to pause and try this one on your own. All right, hopefully you have your answer already. So here's my original bag, which I know is split into 6 pieces. And there were 12 candies in this original bag. So I know 12 divided by 6 is going to equal 2. So each of these is going to have 2 pieces in there. And my new bag is 7 out of 6. So we have 1, 2, 3, 4, 5, 6. So I need to add just one more part to get 7 out of 6. And it has to have the same number of candies as the rest. That will show me that the new bag is going to have a total of 14 candies. All right. So this is how you can visually represent a problem like this. And for this, what you are actually doing is we are taking the number of candies in the original bag, 20, and we're actually multiplying it by our fraction that the new bag would be. So what this means is when we multiply by a fraction, what you are actually doing is 20 times 5 and then dividing by 4. But to make it a little bit easier, we're doing the division before the multiplying. So we did 20 divided by 4, and then whatever that answer was, we multiplied by 5. Same thing on this one. We had 15 times 8 over 5. And what we did was 15, we divided by 5, and then multiplied by 8. And we got the same answer. So by drawing this picture, you gave a visual of taking a whole number times a fraction. Okay, so we're going to go over finding a fraction of a fraction. We're going to do the visual on this, and then we're going to go over just multiplying two fractions together. So you are baking and need to cut the recipe below in half. Draw a fraction strip to show the new fraction you will need for the recipe. So we need 1/5 a cup of butter. So we're going to draw a fraction bar. We're going to split it into 5 pieces. And we originally needed 1/5, so we needed just one of these parts. But now we're splitting our fractions in half. Remember, when we're doing a fraction, all of the parts have to be the same size. So if we split one in half, we have to split them all in half. And now we only need one of those parts. So what would be our new fraction? So there's only one part shaded, and we have a total of 10 pieces. So we only need 1/10 a stick of butter. And what we did there is we took 1/5 times 1/2, and we know that equals 1/10. All right, now let's go to a cup of flour. This one, we needed 1/4 of a cup of flour, and now we need to split it in half. So all of these parts are split in half so that all of our pieces are the same size. Now we only need one of these parts. So again, we need one, and now there's a total of 2, 4, 6, 8 pieces. So we need 1/8 a cup of flour. So we started with 1/4, and we found 1/2 of that. And we just showed that that equals 1/8. Then our next one, I'm going to change this fraction. So I know it says 1/3 cup of milk. Let's change it. We're going to do 2/3. Okay, so here's our fraction bar, and we have 2/3 that we are working with. And we are splitting that in half. So each of these are split in half, and we need half of each of these parts. So now we have a total of 2 parts shaded in out of 2, 4, 6. So what we just did is we had 2/3 and we were finding half of it. So we multiplied by 1/2, and that gave us 2/6. Now, looking at these math problems that we just did, both with a diagram and mathematically, is there anything you notice about these math equations over on the right? Hopefully, what you notice is if you multiply the top numbers, you get the numerator, and if you multiply the denominators, or the bottom ones, you get the denominator. And that works for all of these. So 2 times 1 is 2, 3 times 2 is 6. And that is exactly how you are going to multiply fractions together. You take the numerators multiplied and then the denominators multiplied. All right, so we're going to go ahead and we're going to skip these other word problems. We're going to jump to our observation. What do you notice about the previous 3 examples? So to multiply fractions, multiply numerators, then multiply denominators. All right, so we're going to use that to go through a few examples. So example 7, solve 1/6 times 1/3. So we're going to multiply our numerators. 1 times 1 is 1. And then our denominators. 6 times 3 is 18. Now, when you are doing these problems, you want to check, can it be simplified? So we want to see if there's a number we can divide both the top and the bottom by. This one, we can't, because 1 can only be divided by 1. So that's not going to change our fraction. All right, 1/5 times 1/2. We're going to multiply our top numbers. 1 times 1 is 1, and 5 times 2 is 10. And that's our answer. Example 9, 1/2 times 1/3. 1 times 1 is 1. 2 times 3 is 6. So 1/6 would be our answer. All right, example 10. We have 3/4 times 1/3. So we would take 3 times 1 to get 3, and 4 times 3 to get 12. So now we want to look, can we simplify that fraction? And I know 3 and 12 can both be divided by 3. So I'm going to go ahead, divide both the numerator and the denominator by 3, and that gives us the fraction of 1/4. So our final answer here, after we simplify, is 1/4. So you want to make sure you're not forgetting to simplify your fractions. All right, number 11, 1/2 times 2/3. So we're going to multiply straight across again, numerators together to get 2, and then denominators together to get 6. And 2/6 can be simplified. Both of these are divisible by 2. So we would divide those out, and that gives us the fraction of 1/3. And that would be our final answer. Number 12, we have 3/4 times 1/4. 3 times 1 is 3, and 4 times 4 is 16. Now, 3 is divisible by 1 and 3. 16, however, is not divisible by 3, which means we cannot simplify this fraction. All right, example 13. We have 4/5 times 2/3. So we're going to multiply straight across. 4 times 2 is 8, and then 5 times 3 is 15. All right, so 8 can be divided by 2, but 15 can't. 8 can be divided by 4, but 15 can't. And then 8 can be divided by 8. Again, 15 cannot. That means this answer cannot be simplified, so 8/15 would be our final answer. Okay, our next one, 2/7 times 2/3. 2 times 2 would be 4. 7 times 3 is 21. 4 can be divided by 2, but 21 can't. And 4 can be divided by 4. 21 also can't be divided by that, which makes this our final answer. Okay, so our fractions are in simplest form when the only common factor between the numerator and denominator is 1. So an example here, the only common factor between 4 and 21, we can only divide those both by 1. So that means this is in simplest form. So if you want to go ahead and write down that definition here, you can. Well, you should pause the video to get that. So we have already gone over how to simplify fractions. So if you want to go back and do those problems, you can. I will go through them. If you feel like you are ready to do the practice, you can go ahead and do F3 and G8. Again, you're going to get to a SMART score of 80 on these. All right, and if you feel like you want more examples of how to write a fraction as low as terms, I'm going to go back and do a couple of those problems. All right, let's start example 15 here. Okay, 8 and 28. Right away, both of those are even. So I could start by dividing both of these by 2, and that would give us the fraction of 4 over 14. Both of these are even again, so I can divide by another 2, and that would give us the fraction of 2 over 7. Now, 2 and 7 can only be divided by 1 and itself. So that means this is in simplest form. Now, this is one way to simplify the fraction. Another way, is you could have divided both of these by 4 instead of 2 to start. 8 divided by 4 is 2, and 28 divided by 4 is 7. So if you find a number that's the greatest common factor between them, that'll make simplifying your fraction go faster. But it's also not required to get to our final answer. So you can just keep dividing by a number you know goes in both of them until you can't divide anymore. All right, example 16. All right, so we have 12 and 30, and right away I recognize both of these are even, so I'm going to divide them by 2. That'll give us 6 over 15. Now, these are not both even, but I know 3 goes into 6, and 3 also goes into 15. So that'll give us the fraction of 2 over 5. So another way you could have simplified 12 over 30 is dividing these both by 6 to start with. 12 divided by 6 is 2. 30 divided by 6 is 5. So again, 2 different ways to do the same problem, but the results in the end are the same value. And then example 17, we have 27 over 33. Now this one, both of these can be divided by 3. They're not both even, so we can't divide by 2. 3 goes into 27 9 times, and 3 goes into 33 11 times. Now, 11 is one of our prime numbers, so the only number it can be divided by is 1 and 11. 9, however, cannot be divided by 11, so that means 9 out of 11 is our final answer. All right, our next one, simplify 28 over 49. 28, there are a lot of numbers that go into 28, but 49, right away what I think of is I know 7 times 7 is 49. So I'm going to try dividing both of these by 7. So I know 49 divided by 7 is 7. And 28, if I skip counted by 7, I would get 7, 14, 21, and then 28. So 1, 2, 3, 4. So that gives us 4 out of 7, which is our final answer because 7 is a prime number. So again, those were some examples of writing fractions in lowest terms. So you can go ahead, work on these two IXLs to a SMART score of 80. And let me